Right here, I'm going back to my example with the digits as my universe, and a couple other sets that I have constructed here. And then we'll look at the Venn diagram and how these things intersect and interact. So the universe is my set of digits, 0 through 9. E is the set of all even digits, 0 through 8. T is the set of all triples, 0 through 9 here. And then G is the set of all numbers greater than or equal to 5. So it's the larger 5 of those digits, 5 through 9. Okay. And so when I draw this out, the universe is all the digits. So that's going to be, again, my big rectangle. Oops. All right, that is my universe. And then sets E, T, and G all are going to get their own circle. Now, there's overlap. If I just look at the roster notation, E and G intersect 6 and 8. T and G intersect at 6 and 9. And T and E intersect at 0 and 6. Okay, so there are definitely overlaps in all three of those. So when I do T and E, that might not be big enough. Let's say that's T, we'll say that's E, and then I need G to be in there as well. So there's G. All right, so those are my three sets. Now in set E, one way that we can kind of identify which region each of these numbers in, we can list them off. The number 0 is in both E and T, but not in G, right? So it's in E, it's in T, but it's outside of G, so it's got to be right in there, okay? In fact, that region that contains 0 is what we would say, is what we would call the E intersect T, okay? So E and T intersect in that kind of oblong shape right there. But we don't want something that's in G, we want something not in G. So it'd be also intersected with G complement. Okay, so E intersect T also intersected with G complement. All right. Typically I will put parentheses around ones that I group together here. Okay. So yeah, that'll work. So now that set is a set containing 0. All right, let's see what else we can come up with, where else we can put these numbers. The number 2 appears in E, but not in either of the other two. Okay, so 2 is in E, but it's outside of T and outside of G. Okay, so that would be, if I were to take T, the complement of T and the complement of G, right, intersect those. So T complement intersect G complement, and then intersect that with E. That would have the point 2 in it. In fact, that would give me this whole region. What else is in there? Is there anything in E that's not in the other two sets? 4. Right? 4 is not a multiple of 3. It's also not greater than 4. So 4 would be in that set. And that is it. Yeah. So it's 2 and 4. Okay. All right. What else is in E? The number 6. Well, 6 is in E, it's in G, and it's in T. So we're going to have to look for the region that is involved in all three sets, and that's going to be this middle region right there. That's in all three circles. In fact, it's the only number that appears in all three sets. That would be the intersection of all three circles, or all three sets. So we'd have, oops, you probably don't even need the parentheses on this. It's just T intersect E intersect G. Sometimes we put parentheses on them anyway, even if the parentheses don't technically change the outcome. And in this case, just double checking. Yeah, region 5. Well, yeah, I guess we don't, it wouldn't matter here. So we'll just leave the parentheses off, even though if I put parentheses around any pair of those, I get the same region. So it doesn't really matter. So T, E, and G intersected gives me the set containing 6. Let's look at, let's see, 8 is the only other number in E that we haven't used up. 8 is in G, but it's not in T, so it's right here. Okay, so that 8, because it's in the intersection of E and G, but not in T, it's going to look a lot like the 0 we had before. In fact, it's in a similar position where it's intersected by 2 of the sets, but not the third. And so in this case, we're going to have E intersect G intersected with not T, or with the with anything not in T. Okay, and so that gives me the set containing 8. Actually making good headway. There's only 4 sets left, or 4 regions on here, right? This one, this one, this one, and the outside. Might need a little more space for some of these, but that gives us E is covered anyway, everything for E. Let's look over at T for a moment. We've already got 0 figured out. We've already got 6. Well, we don't have our 3 or 9. 3 is not in either of the other 2 sets. So 3 must be in T, but outside of E and G. Okay, so it's got to be in that region. And 9 is in both T and G, but not E. T, G, but not in E, would put it right there. Okay, so 3 and 9, let's get those sets figured out. This region here with the number 3 in it, that's going to be similar to the 2 and 4. It's going to be a couple complements intersected with a set. So it's actually everything outside of G and E. So everything outside of G intersected with everything outside of E, and then intersect that with T. No, yeah, that's how the textbook writes it up too. Okay, good. I'm on the right track. The number 9 here, the set containing 9, is the intersection of T and G. Notice the intersection of T and G would include both 6 and 9. So we want to be outside of E as well. So that would be intersecting T intersect with G, intersected with not E. So the complement of E. Right, so 9 is a triple, it's greater than 4, and it's not an even number. That makes sense. So all these intersections. All right, so there's 2 more left, one on the bottom and the one on the outside. The one on the bottom here is just in G. So if I look through my list here, 5 was not in either of the other 2, and 7 is not in either of the other 2. So we've got to put 5 and 7 down there. Okay. So I've got that set. So 5 and 7. Write that up down here. That's going to be in G. G intersected with not T and not E. So that would be T complement intersect E complement. And that's a set containing 5 and 7. Lastly, the numbers on the outside here. Anything not in any of these sets. Well, right away I know G contains everything greater than 4. So immediately nothing, 5, 6, 7, 8, those are all out. They cannot be in this exterior. So let's look at 0. 0's already used, 2 and 3 and 4. But there is a number not used yet. It's the number 1. 1 is not an even, 1 is not a triple, and 1 is not greater than 4. So 1 can go in that exterior region, and that region is the intersection of all the complements. So it's everything not in T, not in E, and not in G. So we could say T complement intersect E complement intersect G complement is equal to the set containing 1. Right? And so now I have a way to describe each of those sets, each of the intersections, and the intersections of their complements, right? So it's all kind of combined in here.